Okay, so we're gonna learn about linear regression. Now, what is exactly a regression? So, regression stands for guessing the output which is continuous in nature. Having the example, like you want to guess the person's age, or if you want to guess the person's weight, a person's height, or income, or something like that, or the house or price of a house, something like that. Those things which are continuous in nature means their value can oscillate from minus infinity to infinity. Most of the time it's gonna be 0 to infinity, but okay, in theoretical, minus infinity to infinity. If there's any value that can be there, it means it's a regression problem. So what exactly we do in linear regression is we have lots of points, like we have lots of previous data, which will be plotted on the graph, and we try to find out the best fit line, or we try to find out a line which is which tries to go through most of the points which is there in the graph. Now it's obviously that it cannot grow, it cannot go through all the points, but the one which can go through most of the points, and if they can't go through through most of the points, they are at least very close to the points. So that's what kind of a line that we want to build in a linear regression model. So we'll see what all things will exactly we do. Now you can see there is an independent variable and there is a dependent variable. So the value of x will be completely independent and the value of y will be dependent upon the value of x. That's why we have y is equal to f of x. It means x is completely independent and y will depend on the value of x. Now, this is called a regression line, that for any value of x, you get a value of y, that will be the value of x, and that will be the value of y. Now, independent variable can oscillate from anywhere. Depending upon the independent variable, the dependent variable will oscillate. Now, there are two situations. Mm, when the line is of a positive slope. Now, if you're trying to make a line or trying to plot a line in the graph, it means it's gonna be either a positive slope or a negative slope. How we will decide that which slope it's gonna be? So, if the independent variable is increasing, then the dependent variable is also increasing. Then the line that you will get will be an independent will be a positive slope line. It means you can see if the value increased of the value of independent variable increased, the value of dependent variable also increased. Lines like y is equal to x square, y is equal to 3x, y is equal to 4x, y is equal to x, the lines which are negative, positive in nature. So we'll get a line like this, which so that we call this as a positive slope line. Now, second condition is when increasing the value of x will decrease the value of y. This will give you a negative slope line. The example can be like y is equal to minus x, or y is equal to minus 3x, minus 4x, or any line where the slope is negative. Means if the value of x is increasing, the value of y is decreasing. So these are the two possible lines that you can make. Okay. Now we need to find a line depending upon the x and y, which is which is known as the linear regression. Now, how exactly we find the lines? So for finding lines, we should need some observations. Observations like the unknown data or the training data that we have. Now just imagine these all points are your training data. These points, you know that in the training data, you know that okay, the value, if the value of x is this much, the value of y is this much because of this point. So you have this whole training data. You want to find a line which tries to go through all of the points, and if it doesn't, it tries to come as close as possible. Now you can see these points are like a bit far from each other, so it's not possible that there will be a line which can cross each and every point. Okay, We need to find the straight line which can be close to most of the points. Now, how exactly to find the point? Now, one thing, this was just one terminology, that if there is a line which goes through like most of the points, or stays close to most of the points, we call it as a best fit line, because we can just create many lines. Like you can see this line. Now we'll have one more line which can cross to this point and this point. We can have one more line which can cross to this point. Even they are the linear regression lines, but what we want is the best fit line, or the best condition line which can go past through most of the points. Now we have to find the regression line, and what exactly stuff we use for finding the line is a least square method. Now, what exactly a least square method is? Now, a least, let me see. Come on. What is the name of the line you mentioned? So the line I mentioned is the best fit linear regression line. Okay. So we want to find out the best fit linear regression line. Now, we're going to use the least square method to find the best fit line. Now, what exactly a least square method? So a least square method, as the name suggests, least square. Now, what we're going to do, just imagine this is our best fit line. Just imagine this is our best fit line. Okay. Now, if this is our best fit line, then this line is guessing what will be the value of y if we have the value of x. Now, just imagine this is the value of x we want. Let me take the annotation. Like imagine this is our value of x. This is our value of x. Now, according to the point, according to the line, if the value of x is here, then the value of y will be this point. Okay, but we know, like, let me just go through this line only, like this is x point only. But because we know this point is here, it means the actual answer is this. Okay, so for any value of x, this line is giving you the prediction value, that what the model predicted the answer should be, and this is the actual one, because we know the answer, because it's a training data, we know the answer, and this will be the actual one. So if for any value of x, if the model predicted something, we call it as a y hat, or the predicted value, or y predict, or, and if there's an actual value, we call it only as y. We only call it as y, or the actual value. And sum of squares means we just gonna subtract y minus y hat, which will give you the difference between both the answers and the square of it. This will give you the square of the error. Like this is your error. The distance between these points is your error, and the square of it is the square of errors. And what we do, so what we're gonna do the exact same thing with each and every point. We're gonna did this just for this point and this point. Now we're gonna do the same thing with all the points which are there in the graph. Now if I just start, let's remove all these things. Remove. Now if I just start all the things again, this is the estimated one and this is the actual one. The distance of that will be the error. We're going to do the same thing with all the points. And after doing this thing, like trying to find the distance between all the actual points and the real one, we find the errors, we square it and we add it. Like this is the error, we square it. This is the error, we square it. This is the error, we square that. This is the error, we square that, and we just add all the things. And this is will be your total cost function. This will be your total error. Now if I'll just write like how exactly it's written. So it's let me get the annotation. So this it's like y minus y hat whole square summation of 0 to n, which is the n is the number of data points that you have for training. This is your cost function. This is your error. Now this is also known as the cost function. Why this is known as the cost function? Because this is the thing that you're trying to minimize, because these are things that are giving you the errors, because this is a line and these are your errors, like how far your model is comparing to your actual points. So what you're going to do is you want to just completely reduce the errors as much as possible. It means you're trying to reduce this equation. Like for this particular line, you'll get a proper number. This is the general equation. So you just want to reduce this thing. You want to minimize this thing as as much as possible. This is your cost function and you want to minimize it. Now, these things, you want to minimize it. Now, how exactly it happens? For a normal linear regression, for a normal linear regression, we have a whole proper mathematical formula. We'll go through that in a moment. But let's see for an example. Now, just imagine the conditions is study time and grades. Now, hypothetically, just consider this as hypothetically that if more the study time, more is the grades. So if that's the case, then you'll have a positive slope line or a positive relationship between x and y. Now, if there is a positive relationship, then the equation will be y is equal to b naught plus b1 x. This is the normal straight line equation which you have studied in mathematics like in 10 or 11. This is a normal straight line equation, and this is the equation that you want to find out. Y is equal to b naught plus b1 x. Y naught will be the predicted value, b naught will be the intercept, and b1 will be the slope of the line, and x will be the independent variable for in this condition, which is the study time. So as you can see, b naught is the intercept, b1 is the slope, and x is the study time. This is your condition for finding the line. This is the line that you want to find out. Now, let's take one more condition. More the time on Facebook, less the grades you'll get. Now, even this is a proper hypothetical situation. It's not always true, but let's consider this like more time you're spending on social media, the less your grades become. So this is what you call a negative relationship. Now, in this particular situation, your y hat or like your equation will be y hat is equal to b naught minus b1x. So b naught will be the same, which will be the intercept, same intercept as the last condition. But what is the difference here is minus b1x. Why? Because you have a negative relationship or this negative slope line. Now, if you know, if you try to find out the slope of this line, you'll find the slope of this line will be negative. That's why we have a negative symbol here. And x is again the x value or the independent variable. Now, this is what you want to find out. Y naught is equal to b naught plus b1x, or y naught is equal to b naught minus b1x. How to even find out? Now, as you can see, x is a independent variable, so we can control, we can manipulate, and we can change the value of x. And on the basis of the value of x, we'll get different value of y. Now, how to find out now? So let's take these things. Now let's take one condition, one equation. Now we have value of x as 1 2 3 4 5 and the value of y is 2 4 5 4 5. Now this is like a random condition. We're going to find out how to find the value or the line, proper line the regression line using these values. So we have 1, 2, 3, 4, 5 as x and 2, 3, 4, 5, 2, 4, 5, 4, 5 as the value of y. We want to find a best fit line for this particular equation. How to find it? Now what we're going to do is, first we're going to find out the mean of x and the mean of y. So if we'll try to find out the mean of x and the mean of y, you'll find out x is 3 and y is 4. So we got our point as x is 3 and y is 4 here. Now we made just straight lines for x is 3 and y is equal to 4. This is your mean line. So what you think, what our assumption is that our best fit line should cross from the mean point. Okay, there's one equation, like one assumption that your best fit line should cross through the mean points of all the variables. Okay, now here comes the tricky part. Now we find out two equations or two values, which is x minus x naught and y minus y naught. X stands for all the value of x and x naught x bar stands for the mean value. Now let's find x minus x naught. So 1 minus 3, it will give you minus 2. Now for the next one, 2 minus 3, which will give you minus 1. For the next point, 3 minus 3, which will give you 0. For the next one, 4 minus 3, it will give you 1. For next one, 5 minus 3, it will give you 2. Now the second we're going to find out y minus y naught. So 2 minus 4 is going to be minus 2. 4 minus 4, it's going to be 0. 5 minus 4, it's going to be 1. 4 minus 4, 0. 5 minus 4, 1. We found out x minus x naught and y minus y naught. Now what we're going to find out again is x minus x naught whole square. You just need to take this line and just gonna square it. So minus 2 square is gonna be 4. Minus 1 square, 1. 0 square, 0. 1 square, 1. 4 square, 4. Now what we're gonna find out again? We're gonna find out x minus x naught into y minus y naught. You just have to take these two lines, or sorry, these two columns and multiply these things. Now minus 2 into minus 2, 4. Minus 1 into 0, it's gonna be 0. 0 into 1, 0. 0, 1 into 0, 0 again. And 2 into 1, it's gonna be 2. Now what are we gonna do? We just gonna take the summation of x minus x naught whole square, which is gonna give you 10, and y minus y naught, sorry, x minus x naught into y minus y naught, and the summation, which is 6. Now how exactly we found out b1? Now the formula of b1 or the slope is, if we have different points, different points, and we try to find out the best fit line slope, which is b1. There's a formula given in mathematics that b1 will be sum of x minus x naught into y minus y naught divided by x minus x naught whole square. So that's what exactly we did. That we found out x minus x naught into y minus y naught, did the whole summation. We found out the x minus x naught whole square, did the whole summation, and we put it into the formula. So you can see the formula is this: summation of x minus x naught into y minus y naught. So the summation of x minus x naught into y minus y naught is 6. So put 6 here. Summation of x minus x naught whole square is 10. So we put 10 here. So we found out the b1 value, or the value of slope, is 0.6. Now for this particular condition, we found out the value of b1 is 6. b1 is 0.6. Now what we have to find out? Y naught is equal to b naught plus b1x. We found out b1. What is left? b naught. Now what we can do is, there's one assumption that we took, and the assumption was the best fit line crosses through the mean point, which is 3 and 4. Now if we try to satisfy the point 3 and 4 using the equation, now we have this y naught is equal to b naught plus b1x. We know the value of b1 now, which is 0.6. Now if we try to put the point 3 and 4 and try to solve this equation, now if the line passes through the mean point, which is 3 comma 4, it means y naught will be 4, b naught will be b naught because it's unknown now, b naught plus b1, which is 0.6 into x. The value of x will be 3. Using solving this equation, we get the line. Which is 4 is equal to b naught plus 1.8. Now from this equation we can easily find out the value of b naught, which is 2.2. Now we found out what? We found out b1, which is 0.6. We found out what? b naught, which is 2.2. So finally we got the answer, that our equation is y is equal to 2.2 plus 0.6x. This is your best fit line. So what we are trying to find out from that time is, let's see in ghost and starting, that if we had these points, if we have thing went, go back. So if we have this all points and we try to find out which was the best line, so out of doing all the mathematics, we found out that our best fit line was y naught. Where is the line? Y naught, or y hat, is equal to 2.2 plus 0.6x. So this stands for your final answer. Now you may think that okay, this is a simple thing, but the only thing is, for machine, like what we're gonna do in machine learning is we're just gonna provide this data and the machine will give you the result. What machine does is it's not gonna take this approach. It takes a bit different approach. And why it takes a bit different approaches? Because you can just imagine, for each and every point you have to find x minus x naught, y minus y naught, x minus x naught whole square, y minus x minus x naught into y minus y naught, do the summation, and then find the value of b1. It's fine if you have limited amount of value of x and y. Imagine we have like 1 million values of x, or 10 million values of x. For each and every value of x, the machine has to find out x minus x naught, y minus y naught, the square of that, the multiplication of those two terms. It's going to be really hard for the CPU to handle that amount of data and that amount of computation. So what happened is, machine came up with a small trick, or not even trick, like a small way to find out the best fit line, but not using this, using something which is known as a gradient descent. Now we'll see, like we'll not completely go into like what exactly happens in gradient descent, because if I'll try to explain what happens in gradient descent, it'll take like 2 hours. So we'll go through the basics, like what exactly gradient descent works is. So if I'll just show you using my paint, where is paint? Paint. Let's use paint for now. Paint. Let me remove this. Cool. Now what happened is, we have the line, we have the different points here. These are normal points. You want to find a best fit line. Now what happens is, what happens this one. Okay. So what happens is, we need to find this best fit line. Now I've told you about the cost function. Like for any best fit line, we just want to make the cost function as minimum as possible. It means the cost function was y minus y bar, sorry for my handwriting, whole square. This is the cost function, y minus y naught, and we want to minimize it as much as possible. Sorry, minimize it as much as possible. Now you can see y minus y hat whole square. Now what is y hat? Y hat is what? Y hat is mx plus c, or if we'll just see the equation that we have saw before that, it was b1x plus b naught. So if we just take this term and put it here in y naught place, it means it's this particular equation square. It means it's the equation of x square. If you just break it, you'll get b1 x square, b1 square x square plus b naught x square plus b1 and b naught b1 x into 2. So you'll get an equation which will be the equation of x square. So what exactly equation of x square looks like this. This is the equation of x square. Like, this is the equation of x square. If it's negative, like this, keep it as keep 0 here. If you keep 0 here, then increasing, the value of x increases. Even negative also, the value of x decreases, the value of y increases. Now if you're going to try to plot this graph, like plot y minus y hat whole square, and you plot this graph, you'll get some kind of this shape only, because it's going to be equation of x square. Now what this is giving you, this is a cost function. This is a cost function. It means this particular y is cost function, cost. Okay, and what is this? This is the value of x. Okay, this is cost and this is x. Now what we want to do with this function is try to minimize it as much as possible. It means we want to find any point in this line, any point in this graph where the value of cost is minimum. Now you can see from this point, the point where the cost is minimum is this point. This is the point where the cost is minimum. And what is the different, like a special thing at this particular point, that if you try to find out a tangent, like try to hmm, hmm, you can just find this point. And how to find this point? So if you'll get a tangent at this point, you can see the tangent's slope is 0, and that's what we find in derivatives. What exactly we find in derivatives? The slope of the tangents of any curve. If you have studied geometry in like 11th and 12th, so what exactly you find in the, so what exactly try to find in the slopes, like in the curves? If you just find the derivatives, it just gives you the slope of the tangent. So we're just gonna find any point where the slope of the tangent is 0. As simple as that. Now how to do it? So what happens is, we're just gonna take any random place, literally any random place. We take any random place, not take this, take this one. We take any random place and we find the slope. We found the slope. Now we can see the point is here and there's a positive slope. Okay, this is not 0. Now what we do is, we slowly descend towards the 0th point. Like, okay, this is the high slope. Now what we're gonna do, we're gonna find a point which is a bit lower to this. So we'll try to find that slope here. Now it's gonna give you a bit lower slope and a bit lower cost. Now, but this is also not 0. So we'll go more further down. We'll make this line. We'll try to find the slope here. Now even this is a bit lower cost, but still not 0. Finally, we'll reach here, which will give you the whole cost as 0. Sorry, whole tangent as 0. Tangent slope as 0. Now, when we found out a point where we get a derivative of 0, it means this is our minimum point. This is our minimum cost function. So we got our value of x from here. So what will be the value of x? This is what gradient descent is. It means slowly we're descending towards the cost function, the minimum value of cost function. This is a gradient descent in like a rough way. Now there's one small problem with gradient descent is, let me just get the eraser. So there's one problem with gradient descent is, I have shown you that you have this graph and you try to find out the bare minimum point. Now it's not always like you'll get this kind of graph only. There's a possibility that you'll get this kind of graph. Completely possible because of the equation. So and you're finding a derivative from here. From here only you'll find your derivative. Your cost function 0. So this is what you call a local minima. We want to find the global minima, but we are stuck in the local minima. And gradient descent has no way to find out that the solution that they found out is either a local minimum or a global minimum. So what happened is we use something called as a stochastic gradient descent. What we do in stochastic gradient descent, as soon as we found a local minima or any minima, we just make a big jump. Like we make a learning curve jump somewhere in the graph, anywhere. It's not necessary that you have to go forward or backward. Just make any jump from any jump anywhere. And like just imagine we came here. Now we'll start doing the same thing here again. Again finding the minima, 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 and again we drain this minima. So what happened is just jump here and there and find 3 or 4 minimas, and then comparing to that minimas they'll see which minima is actually the lowest minima in comparison to all the minimas. So that gives us a chance that okay, this particular this particular algorithm can get you the global minima. It's all, again, it's not uh, let me just drop this thing. It's not assured that it's going to give you the global minima all the time, but it's tells you that there is a chance, because normal gradient descent it cannot. So if you have this particular graph, jump till here, you got this minimum also, you got this minimum also, fine. It will compare and it will give you the global minima. But there's again a chance, like happens is you have this graph, it jumped here, you found it this minima, you found it this minima, you found it this minima. The stochastic gradient descent didn't find this minima. So it's just gonna compare between all these three and give you the best minima comparing to all the three, not the global one. So even this can happen, but still it's better than the previous example because it's not going to even check the other minimas. At least in stochastic one, it checks other minimas. So that's how the machine does the model. So if the thing that I've showed you just now, this particular mathematics, it's just the regression that we as humans do on paper. If the machine does any regression line, it doesn't go for this equation, it goes for the gradient descent. This is what a gradient descent is. Now, till now you have understood what is the exact mathematics behind uh, simple linear regression and what is the rough idea of gradient descent. Tomorrow we'll see how to write the code of it. So tomorrow we'll see how to write the code of it. So it stands end of this class. If you have any doubt, you can just type in your questions right here. It's the remaining time is only 4.27 seconds. So type your questions as fast as you can. And if the time gets over, it's fine. You can just give me a message on your WhatsApp also. If you have any question, you can just ask. Waiting. And if you have no questions, then you can just give a thumbs up or anything. Okay. So I will give a thumbs up. Okay. Even Tanisha gives a thumbs up. Avinash gives a thumbs up. Nice. Okay. So it's good that Vinishada gives a thumbs up. Okay. So to be honest, I don't think that you all understood what everything I've said. Okay, that's what I feel. So the thing is, even if you understood like 50% of what I told right now, it's completely fine because this is your first algorithm that you came across. And to be honest, they are like, I've seen many people who are really good in writing the code for any algorithm that you can name on, but they have no idea how they're working on. Because what all I have taught you right now, what all equations that I've taught you right now, to do all the things in machine learning using Python, you just have to write two line of code. That's it, exactly two lines. All the things that you have done till here, all the big mathematics terms that you have understood, it only happens in two lines of code. No more, no less. Exact two lines of code. The model is ready for you. So the important thing is that you understand what exactly is happening in behind the two lines of code. You can literally just use that two lines of code to make any algorithm. The two lines of code will be used in all the algorithms that you will see in machine learning. Tomorrow we'll go across the code, and then you will understand that okay, the algorithm behind it, it looks a bit difficult to understand what exactly is going on, but to write the code, it's extremely easy, because all the things that we have to do, like all the mathematics that we did here, it's previously pre-processed and saved as a function in libraries of Python. That's why we use Python for machine learning. That's all the things are predefined. You only have to just go call the function and your model is ready. You don't have to do anything, no hassle at all. So this stands for the end of today's class. If you have any doubt for this session, you can just text me on WhatsApp, and tomorrow we'll go through the code of simple linear regression. And again, day after tomorrow, we'll take one more class for a logistic regression. Okay, then, bye bye, class. Let me stop the share.